Hello, everybody. I'm Robert Kelly, VP of Innovation, Liatrio. Real quick on Liatrio, we're focused on building better businesses through technology, right? And that is all things technology modernization and enablement. And over the past year plus, we've been working towards making the AI native transition real for ourselves and, of course, our clients as well. And that's why we're here today. We're going to share what's actually working and working well for us. And that's really what we're getting into. So the theme here is AI coding agents aren't failing because the model is bad. They fail because the instructions are bad. We want to share spec-driven development, how that's making AI assisted engineering reliable and repeatable. So let me hand it over to Damien.
Yeah, thanks for the intro. Damien Storm, lead AI Enablement Engineer here at Liatrio. Yeah, to piggyback off what Robert said, like it's coding agents don't fail because the model is bad. They struggle with bad input or with not understanding how the tools are designed to work. And we're here today with our SDD workflow to show you how you can make the tool work for you. You need to understand the techniques and the workflows behind these and how these models and these AI tools work. So without further ado, here's the roadmap for what we're going to cover today. So we got that. Oh, hold on a second. I think my screen share got a little messed up.
Still see it, but yes, it's not moved
Yeah,
to the next.
let me fix that real quick. Here we go. Awesome. All right. So you guys should be seeing this
Got a little,
now.
got a little
Okay.
bit of a split screen here. We still
Yeah,
see.
yeah, yeah.
We'll get there, folks.
Thank you for your patience. There we go. So first up, we've got why SDD. This is an overview of how the SDD workflow works to really guide the AI into what you're trying to do with whatever the work you've got right in front of you. It helps establish all the techniques for working with AI and shows you we'll go through all the ways that it solves the problems that AI introduces, right? AI does a lot of things really well, but it also complicates a lot of things. So next up, we'll go through context engineering, right? So context engineering is an extremely important part of how you work with AI. So we'll go through context rot, the context window, and how getting your repo ready to work with AI is really one of the most important things you can do. After that, we'll go through the workflow, how specs, tasks, and the build and verify steps will give you everything you need to know to work with AI to build the thing that's in front of you. After that, we're going to go through the evidence-based execution. So why the proof artifacts and all of the results that the workflow builds help create all these validation gates that keep what you're doing very reviewable, on track, and guides the AI to exactly what you're trying to do. Then after that, we'll go over the patterns that we built in and show you everything that we've gone over and give you some next steps, like how you can start using this with your teams to build with AI and build with confidence. So let's start with the
Yep.
core
Just some
problem.
logistics
Yeah,
here. Not to cut you off. Sorry.
no, yeah,
We've got a lot of content to share, and we won't be stopping until we get into a little bit of the demo and have some breaks. We've got some of our friends backstage helping out with the Q&A during the presentation. So please feel free to uh, uh, present your questions, add them to the Q&A section here in Zoom, and we'll try to answer them as we go. But we will be able to answer some questions live when we get into the demo section. So thanks. Sorry, Damien. Go ahead.
no problem. All right. So next up, and actually, I got another logistics thing I need to fix real quick. There we go. Sorry about that. All right, so now nice and bright, you can see it a little better. So AI gives us speed. Everybody's experienced AI, everybody's worked with it now at this point. You've seen the incredible speed that it can give you, whether it's generating code, creating images, helping you draft responses for emails, whatever you use, it gives you speed. But what we found out is speed without direction gives you a lot of failure, right? It's causes rework, it causes time-consuming effort that you have to go into and redirect it or give it like, nope, that's not what I wanted. Go back and start over and over again. So what you really need is a tool that gives you the ability to create that direction very quickly and very consistently. So let's just walk through what it looks like when AI works really well, and then some of the failure modes that you can run into when you don't have this good setup. So we've got three steps across the top, right? We've got research, planning, and execution. That's what every AI interaction really goes through. You got some clear framing for your problem. You've got it really well documented. You've researched it. You understand how you want everything to be built, and you've got it planned out. So that make sure that everything from your idea or your feature that you want to build, you've got an alignment that you maintain into a very explicit plan that you then hand off to the AI. Then, after you've got that explicit plan, you go through the execution. AI builds it all super quick, builds it exactly how you wanted, and at the end, you've got what you asked for in a very quick fashion. But what happens if something goes wrong? Let's say maybe when you were doing that plan, you left out some context, something about maybe some architectural detail, like the endpoints that your app needed to use to talk to something, some external service, or maybe some kind of guidelines about the formatting for the outputs that the product was supposed to build. Now you've got something that the AI built that's very plausible. It'll work, but it's not what you asked for. It's not what you needed. So that's one of the failure modes that you can get into, and will start getting you from aligned into off course. What about if we have some assumptions that we leave unstated at the beginning? So you maybe have a plan and a very clear idea, but you didn't communicate all of that to the AI. You assumed it has the knowledge that you do, and it wasn't explicitly stated. So now we've gone from an explicit plan into an implicit plan. There are things that have been left out, ideas and details that haven't been communicated to the AI yet. And now we go and we see that those gaps in the plan, they get filled by the model. All that training data that you're not responsible for, that you didn't create, now gets pushed into the execution. You're back to plausible but incorrect. There's other ways it can fail though. For instance, the gaps that filled in, we've seen how fast AI can work, right? It's all about the speed. AI starts making guesses about even more things, like other implicit stuff that and assumptions that you didn't bake in. Now it's guessing at AI speed. It's making all of these assumptions, and now you're in a place where it's very fast, but very confident, but it's a failure. Like it doesn't do what you need it to do in any way. There are a few other ways that we can get to this state too. What if we've got ambiguous framing instead of a very clear idea of what we want? Let's say we've got, just something we want to vibe code. Like, give me this app. It's got these five features and go. And that's all the plan. That's all the research that you give it. So that takes us into a bunch of ambiguity, get into an implicit plan, and we've got this failure mode again. But it can go even worse. Because we're not giving it a very clear plan up front, there's even more assumptions that it bakes into. And now we've got misalignment baked into this plan that we haven't reviewed, we don't know about, and all of a sudden we've got misalignment that's amplified because AI it happens at every stage of this, right? AI, that speed amplification, everything from the beginning gets amplified over and over again at every stage of this. So that's another way we get to a very fast, very confident failure. And the reason that this can go wrong so quickly is because it comes down to one constraint. This is the thing that we need to talk about most with any kind of AI work, and that's the context window. So the context window is the most important thing that you're going to be dealing with anytime you're working with AI. It defines everything about how the AI works and everything about what the AI understands about what you're asking. So you can think of the AI context window like imagine you're working in a workshop, right? You've got a workbench, you've got tools on the workbench, you've got the project you're working on, and you've got a finite amount of area on that workbench. So the more tools you bring in, the more components of the project, the more pieces you bring in, all of a sudden the workbench gets full really quickly. And the fuller it gets, the more likely something's going to get pushed off the edge, right? That tool that you needed to do the next part of the project now it's laying on the floor and you can't access it. You can't work with it because it's not in the workbench area. It's not in the context window. So to take it back to the AI tooling that and map it to the analogy back to like the AI stuff that's going to be involved in this. So think about your system prompts. Think about your user messages. Think about every tool call that you've got. Every time you have the AI read a file or go out and read a website or do any kind of loops, or all the tools you bring in, like any MCPs you've got involved, all those tool definitions, all of that goes into the context window every single time you hit enter on that prompt. So when you type in a new instruction, the chat window really presents this illusion of how the AI works. It's not sequential. It's not every time you hit enter, the AI thinks about just the new thing that you're bringing in. Every time you hit enter on that prompt, the entire context window goes back to the AI. So all of your directives, all of your evidence, all of your capabilities, they all go back to that. They all have to be rehashed like a brand new stateless interaction. AI doesn't have any memory when you're working like this. It just reads the entire conversation again, reprocesses all of it all over again.
Yeah.
So
That
yeah,
degradation happens. It doesn't happen quickly, but it can, depending on how much you're giving, how much context you're giving it, right? So, with these latest models, they may advertise, "Hey, we've got a million tokens in a to context window," but the real empirical evidence shows that all of these models, the frontier models, the best models we're using, they start to degrade pretty quickly after about 100,000 tokens. So even if it says, "Hey, we've got a million tokens available," it starts to degrade pretty quickly after that. And that really, for the folks that need a little more context, that's about, well, 400,000 characters, right? And the it just happens. This is what it gets. The more context it has to parse, the dumber it might end up, right? So it just comes down to being mindful of that window, and we'll get into that a little bit more.
yeah, great call out. Like the graphic shows, like even with these large context windows, 200,000 or a million with the latest models, that's not the only thing that matters, right? There's a lot of research that has shown that context threshold for some models it's 50%, for some it's 40, for some it's 60. But beyond that certain threshold, the more you put in there, actually the worse the model performs. There's this sweet spot in the middle. So managing, think about it like the workbench analogy, right? If you've got all of your tools in your project and it's filled up like 100% of your workbench, you've got no room to work. You've got no room to move things around and think about different ways to approach the problem. It's a similar thing here. So you need to be able to control the context window very specifically. You need to control what goes into it, what the AI is looking at for each turn of the conversation. And that, because when that workbench gets overloaded, you hit one of the most common failure modes in AI, and that is context rot. So, context rot is the idea that, that very important tool has fallen off the workbench, or that important document about how this particular API contract is supposed to work is no longer even in the focus of the LLM anymore. So you have to avoid this failure mode. And the way you can do that is by resetting and starting over a new conversation. There's this term called serialized external state, where that's one of the AI techniques that you can go over on our website, where we talk about how offloading some of the things you're working with AI out to an external place where it can reference instead of depending on that chat and that chat history is one of the best techniques you can use to manage context rot. You'll see it. We've probably all seen it, especially on websites like ChatGPT or Claude, where you just have a super long conversation. All of a sudden, it's forgetting things. You're like, well, I'm trying to redirect. Why didn't you do it this way? Or we've already talked about this. Why didn't you remember that? Anytime that you're experiencing the problem of trying to redirect an AI in a chat, that conversation is gone. That conversation is toast. It's time to just try and extract what you need out of it, put it into a new chat, and start over because you're not going to be able to recover from that doom loop of like the AI has lost too much. It's trying to focus on too many things and it can't keep track of all the different stuff you've overloaded it with. Um, a good example of this for software engineering specifically. So think about you've got very specific repository guidelines, like maybe the way conventional commits are handled, or you only want your websites designed with a certain specific design pattern, or your controllers have to follow a certain model. The AI has to think about that in every turn of the conversation. So if you've overloaded the context window, then all of a sudden those specific guidelines that you want it to follow, it can't keep track of them. They're not in there anymore. So that's one of the reasons you have to very specifically manage your context window. So yeah, that's some of the failure modes that you can get into when you're working with AI. The next question is why we built SDD the way we did so that we can manage these. Right. So why SDD? We built this workflow to solve some very real world failure modes to get over how we've encountered those and how to help you guys avoid them in the future. Context management, vague tasks, and even tool lock-in. Like there are a lot of vendors and a lot of other tooling out there for doing this kind of spec-driven development. Things like Spec Kit from GitHub or Taskmaster or Kiro from AWS. And they work. They absolutely do help you focus what you're doing and get the AI to build what you want, but they have very specific ways of doing it. They have their own very opinionated stack that is often very hidden, right? Like if you spin up Kiro or even GitHub Spec Kit, you can walk through the steps, you can see what it does and see the output, but you don't know how it did it. It's not telling you about the flow, it's not telling you about the process, it's not telling you how you can take these processes and this logic and use it outside of this tool. It also really fills up. They have a very specific way that they want all of this to work. Like they add entire directories, a whole new lexicon of different terminology you have to learn to use these tools. There's a lot going on when you're using them. They're complicated. They do work, but they don't work for a lot of the clients that we've seen. Like for the enterprise clients, their software engineers, they can't abandon every aspect of their workflow and just dive into a whole new tooling set. They need stuff that is going to work with the flows they already have established. So that's why we built the Liatrio SDD solution. There's a lot of things to like in here. It's got very transparent. It's just four simple markdown prompts that we're going to go over that anybody can read through, anybody can adjust. You can make them customized to your workflows at your job. We'll go through the different pieces here and see exactly how it works. Let's see. Big part. Yeah. So a big part of getting this right and making these workflows work from the beginning, the first thing you have to do is make sure that you've got the right work set up. You're bringing the right size of problem to the workflow in the first place. So let's see. Yeah, right size
Yeah.
work.
And chime in here. Like this is where the industry is moving. You know, Damien mentioned a few. There are other workflows like the BMAD workflow and things we like these a lot. All of these, the way these things are working and planning ahead of time and getting the specifications outlined. These are all working themselves into the harnesses that we're building, right? So Claude Code's got plan mode. And these are great, and we'll talk about where some of these decision points are. And hey, when do we use spec-driven development versus where do we use the tools and the baked-in tooling? Anyway, but this is where the industry is coalescing on right now. So we know we have to plan to manage context.
Sorry, I got a little desync there. So, right size work for the workflow. The first thing you're going to do is think about what you're bringing to the SDD workflow. What do you want to build? What is the goal? What is the output that you want? The workflow is specifically designed from the perspective of an engineer that has to sit down and get his work done for the day, get their work done for the day. So it could be a Jira story, could be a GitHub issue, could be a feature idea they've had for an existing app, something that they need to focus and write some code for and then have a producible output. So that's the first thing to do is think about how you're going to engage with this workflow and what the work is. If you ask it to, fix world peace, it's got some logic gate in there to help figure out, okay, that's a little big. This is not really what this workflow is designed for. Or if you come in and ask it, hey, we need to change the button to blue and change some copy text on the website. Then it's going to say, okay, that's a little small. You can probably just edit that yourself or even vibe code it. So the thing you want to do is think about Goldilocks sizing, right? Not too big, not too small, but just the right amount of work that an engineer would try and sit down and do in a day or two. You don't want to over-engineer minor changes, and you don't want to under-specify large re-architecture changes. Yeah, so to make this concrete, let's show a little bit more about the app we're going to use for the demo now that we've talked about the kind of work you want to bring into it. So next up, we've got our example app. This is just a Java, very simple app. It's a website. It's set in a very approachable, recognizable domain. Everybody understands pets, owners, vets, visits, all of that stuff. So having a domain to explore SDD and learn how to use it is crucial because you don't want to have a lot of overhead of a new app, new concepts, all that kind of stuff. So we built this domain. The other thing that's very important about using this particular app is it's very tailored to SDD and working with AI native development. It's got all the guardrails built in, pre-commit, a strict test-driven development workflow, and playwright end-to-end test, an automated code reviewer that is an expert on the framework that will follow up and look for very specific things. It's got a lot of guardrails in there. And let's talk a little bit more about those guardrails for a repo like this, where you really want to have it set up to make your AI work very well. There's a first step that you have to do before you even jump into the workflow whatsoever. And that's a phase zero. You got to make the make the repo AI ready. These quality steps shape how the agent works before you prompt even the feature at the very beginning, right? You have to have documentation, you have to have architecture, you have to have a good developer experience. Think about pre-commit and how that helps ensure the code that you write as a human follows all the standards and all the ideas and the concepts that you already have set up, right? Those decisions have already been made. You don't want to repeat yourself on how those work or have to think about those guardrails every time. You want to set them on autopilot. All of that dev experience, that developer experience, benefits the AI too. So getting that set up really helps set you up for success with AI. And then tests, right? So if AI gives you speed and helps you go faster, then the need for testing and the need for guardrails and the need for like this ability to really understand and keep your goals and your speed aligned goes up infinitely, right? You need tests to make sure that everything you're building is working the way it's supposed to make sure when the AI adds new stuff, it doesn't break old stuff. All the old reasons for tests are only amplified. That's one thing we talk about a lot. Everything, the biggest thing that AI do is it amplifies everything. It lets you go faster, but it also amplifies the potential to go off the rails. So you need to have those guardrails in place to ensure you've got this safety net set up and can engineer this context that agents need for success.
Yep,
Um,
that's really big here is we're engineering for agent experience, not just developer experience anymore. This is huge for making sure that we get the most out of it. So agent experience is going to be a big thing going forward. You're just going to see a lot more of that. So thanks.
yeah. Thinking about who you're building for. Right. So once you've got the repo ready, once you've got it AI ready, let's talk about the workflow structure we're going to apply on top of this right-sized work that you're bringing. So the STD workflow. Here's an overview. Phase one, we've got the spec. This is where you bring in that right-sized work and you ask the AI, hey, this is what I want to build. Help me generate a spec to do that. It's going to ask you some questions. It's going to make sure it understands all of the contextual information it needs, and then generate this spec that's going to be your work plan for the rest of the phase. We'll go from that to phase two, tasks. So this is where you have the AI generate the task breakdown from that spec. So you get some high level tasks, you'll get subtasks, and then you'll get some notes and some ideas of the proof artifacts that need to be generated to create a successful implementation of all those tasks. Then it'll have a sign-off gate. You're going to look through it, you're going to review it, you're going to make sure it aligns exactly with the output you expected for this ask you're doing of the AI. I want to pause and point out that for STD and for anything with AI, really, these are the most important aspects, right? This phase one spec and this phase two task, this defines everything that you're asking the AI to do. This is that direction piece from the earlier slide, right? AI gives you speed. This is where you set the direction. This is where you set the guardrails. It's going to generate a lot of text, and that's a different skill set, like to like look through all this text. But this is where you make sure the AI is going to produce the output that you want. This is the setup that lets you take advantage of all of that speed. Next step, build, right? So now that we've got our spec, we've got our tasks, and we've got this direction set up, now it's time for us to hand it off to the AI and let it do the work for us. Let it do all the builds. It's got built-in logic for verification loops for each one of the tasks to make sure what it built lines up with what it was asked for, and it has guardrails to make sure everything is going the way it's supposed to keep that direction and that alignment where we want it. From phase three, we go to phase four, where we verify how everything's working and verify that everything that was built goes all the way back to the spec and lines up. So yeah, that's an overview of exactly how it works. Let's see. Anything else we need to do here? Nope. All right, so let's start with phase one, where we turn a request, that right-size work that you started with, into a usable contract that the AI and you can work on to make sure we're going to build in the right direction. So there's a few techniques that we use in SDD1 spec here. We've got task decomposition, we've got progressive disclosure, serialized external state, and dynamic context injection. So these are some of the AI primitive techniques that we need to implement whenever we're working with AI. We've got more about this on our website. We can go over that later at the end when we're taking questions, and we'll have links for that too. So everybody can kind of understand these AI primitives and use them when you're working with AI. I'm going to go ahead and get my terminal set up here. Let's see.
Just to add, we've been using the this approach for months now, and we've taken it to multiple customers, and they're seeing a lot of success. We've got a lot of good, client testimonials for how well this is going, and just so we're seeing this in the real world, and it's been really helpful for us. So we want to make sure we're, sharing it and improving it as we go.
Yeah, yeah. So I've already cloned the repo. We'll have a link for this as part of the resources too. So we're in the repo for the Emerald Grove Pet Clinic. Let's take a look at, let's go ahead and open up Claude. And I want to point out, I'm going to run with skip permissions just for the purpose of this demo. We need to go fast. We need to kind of make sure we don't have too many blockers here. So I'm going to run that. In the real world, make sure you get this all set up for yourself. You've got your permissions set up the way you need to. So let's go ahead. Let's see what's up on, we've got some issues outlined already in the repo. Let's ask Claude to take a look at them and give us an idea. Okay, it's using it. It's found them. All right, we've got a few different issues here. Right, so let's check out number three here.
Yep. So all these
Vulnerable.
issues are set up already on the repository that is cloned down, and we're going to pick a issue from the list to work on. So we're doing it live. We just cross our fingers, again, the non-determinism here, and we assume that our friends at Anthropic are going to have their models running. So all of those things have to work.
Yeah, so let's fingers crossed, no outages from Anthropic today. All right, cool. So we've got some details that is pulled from GitHub. This looks like a pretty basic issue that we could get started. Let's go ahead and try it out. So right, so I've got another branch already open. We're going to do a new branch. So you can see here, I'm going to tell it to open up a new branch, and we've got the STD prompt set up as slash commands in Claude. We've got an entire utility for setting that up for your own tools. That's on the STD repo, be part of the links. It works with any of the major tools, right? Like Claude, Cursor, Windsurf, Codex, Gemini, open code, all of those, you can do this exact same workflow. That's one of the benefits of the way we've built SDD. It works with whatever tools you want. It works with whatever AI you want. It comes to you, and that's one of the things that makes it so flexible and approachable.
That was really huge for us because we like a lot of tools. Our engineers use different tools from project to project. Teams at our clients use different tools from different. Yeah, they're just using every tool imaginable, right? So it was really important to have a common workflow, so we'd have a common language, understanding, and approach to accomplishing this work. So that's been huge. And now's a good time to queue up some questions if you have them, please do. We probably have a couple of canned questions we can ask to answer as we go, but there's going to be a little bit of we'll just say waiting here as we go through this. we'll talk through some of the things that are happening, but please queue up your questions if you have them.
So we can see here, it loaded up the prompt. It created the new branch for us, and it loaded up that skill for STD1, generate spec. The first thing it did, it searched for patterns in this repository. So it's going through and it's searching for that context, that phase zero AI ready repo stuff that we've already talked about, we've already set up here. Right? So before it writes any code, before it even writes the spec, it wants to really ground itself in this repo, make sure that the context has been set up to understand what it's trying to do and how the ask from the user, what we tasked it with, is going to be affected by this context of the repo. Right. It also did, yeah, so scope assessment. This is what we talked about, that like Goldilocks moment. It did the logic to judge, okay, this task actually fits in just right, right? It's not adding a whole bunch of stuff and it's not too small. It's appropriate for the workflow. It also has got some and directives in there to go and do a little bit of existing web research, right? Like go out, check modern standards for the technologies and the tools that are involved in this code base or in the ask, and see if there's anything that the model needs to know. Because we don't want to always depend on training data. These models are very smart. They've learned a lot, but the world changes fast. We need to keep them grounded when we're doing these asks in modern and useful techniques. So let's see. We've got okay. So the app does ask, or sorry, the workflow does take a moment and it'll ask you if there are any clarifying questions it needs to. It'll generate a whole doc. But if there's none needed, if the task that you gave it was scoped well and had all the details, it's going to skip that. It's got everything it needs to know to build it. We'll show an example of what those question files look like in a separate demo a little later. Um, it's got a little validation loop where it looked through everything and then it went ahead and made the spec for this. And yep, we've got the spec file. There's the doc, scope assessment, 3 dimmable units. Okay, let's go ahead and take a look at that spec that it generated and see what we've got here. Quick tour of the terminal, right? So I've got Cloud Code here. I've got a few other tabs here that we're going to be using. This one, just a simple file browser. Here, this is LazyGit, something to use for viewing the Git status of things. You can see we've got a new file in here, this new spec, and then we'll go over those a little later, the other tabs. So let's go ahead and open up this spec in a tool that we can look at a little easier. Let me make this text a little bigger. So this is the spec that is generated. Feature adds an upcoming visits page, purely informational, no editing. We've got goals outlined, right? All looking good. We've got some user stories. As a clinic staff member, these are all the things I want to be able to do. Then we've got the demoable units of work. So these are the deliverables for this that the AI is going to create as it goes through and builds the spec. Core rendering, right? Got the proof artifacts that it's going to generate to make sure that this works the way it's supposed to. Then we've got unit 2. Okay, going to add the navigation link. After we build the page, we need to make sure people can get to it. Got some proof artifacts for this. We've got an end-to-end test from Playwright to make sure that it shows up. Yep, validate the full user journey. So proof artifacts, yep, another test, Playwright test run, and then some more XML test results. Cool. Then we've got some non-goals. These are things we're not worried about. When you're scoping work, right, it's almost as important to talk about what you want to build, to talk about what you don't want to build as it is to talk about what you do want to build. So non-goals, this is part of the alignment that the SDD workflow does with the user. Are these the things that we're concerned about? Are we sure we don't want to build any of this other stuff? So yeah, we don't care about pagination, no filtering, no sorting controls. Yeah, this all makes sense. We've got design considerations. You can see where it pulled in the repository context, right? And there's conventions already built into this code base that it's going to use to build this new feature. Yep, and we've got more standards, test-driven development, commit conventions. pre-hit hooks, yeah, all the stuff that a junior developer, like a human coming in and trying to do this work, would need to think about when they're working in this repository. SDD makes sure that all of those conventions are followed and set up. More technical considerations. You can see how much research this did to really understand what it's trying to build and how what it's trying to build slots into the existing code. No
Yep.
security considerations. Go ahead.
And this is just the difference between having a plan and just vibe coding a solution, right? You see here, we're taking time to review the specs, review the plan, and understand actually what's going to happen. And we're going through this pretty quickly, but for what needs to get created, it we really do need to take some time and review and edit where we might need any changes. Here, this is going to because the things are planned out pretty well. We probably don't have any changes, but it's really important to validate before we get into the loop of actually going through the work.
Absolutely. Yep. So no security considerations for this. It's read only. It's basic app. One thing I do want to point out, right? So there's a lot of the tools that we talked about earlier, SpecKit and Kiro, they feel very much like a lot of times they're designed for greenfield work, right? Like you've got this great idea, you want to build this whole thing out. Um, the This demonstration is designed to show how you can use SDD in these spec-driven workflows to build in a brownfield space, right? Like an already established application. That's a big concern that a lot of people bring up is, well, how do I use all these AI tools to work with my current apps? And this is a great example of how SDD can take all of those considerations. It goes through and looks through the app, make sure that it's grounding itself in your current brownfield code base to help set you up for success. Um, the Make no illusions, like the pet example app, it's not huge. It's not 10,000 lines of code. It's small, but it shows you how this can work in a established application. So we've got our success metrics here, all test pass, unit integration test, page renders correctly. It's going to load some screenshots and the proof artifact. All right, and then we've got some questions, a little input from us. Have an upper bound. Yep, should. And then the other one. Oh, it's asking us from positioning, like where do we want this to look? Honestly, wherever you think looks best. Not super invested in answering that. Cool. So now we've got our questions answered. If we close this guy out and we go back to Claude and we'll tell him questions answered. It'll read the file, incorporate those into an update in the spec, and then it should prompt us for the next thing that we need to do. Yep, there's the edits to the spec. It put in the 90 days. And then it figured out where to position the link. Okay. And then it updated spec, say no open questions. All right. So this points out something that's important to remember. These these specs and these tasks and all these planning artifacts that the SDD workflow generates, they're not written in stone. This is a back and forth between you and the AI. This is where you are aligning your vision and your plans to the specs and the tasks and these files to make sure that they are working exactly the way you want. Don't You can have a conversation with it. I've had plenty of conversations where I talk about the spec for half an hour, depending on how large. Like this planning mode is the back and forth where you want to make sure that everything you're doing here is aligned. Um, cool. So we've got our spec. Yep, it's finalized. I'm pretty happy with where this is. One caveat for the demo, right? Like we're breezing through the spec a little bit. Reading through it when you're working on actual work, you want to go through it line by line because these are the directions you're setting. This is where you're telling the AI to go. So if you don't read through this, you don't fully understand it, you're going to end up somewhere that you didn't want to be. That whole plausible but not correct solution from the slide in the beginning.
Yep.
Right. So,
Echoing that, that's super important here. Just anecdotally, we hear some questions, concerns from engineers who are talking about, hey, are we expected to abandon our, critical thinking skills? We're just prompting a model and expecting it to come back with good code. This is where the shift happens, right? We're being way more intentional about outcomes here. This is focusing on outcomes specifically, and this is where critical thinking needs to be at its highest, is understanding the intent, and so the outcomes are good. And we're not abandoning critical thinking at all. It's like we expect people to go in and read these things. Like our engineers are very intentional, right, with the specifications, and that's thinking really gets us thinking about what the customer needs, users need, and focusing on the outcomes. And I think that's going to be one of the bigger shifts here.
Absolutely. Right, so now we've got the spec laid out where we want. It's prompted us to run the next part of the workflow. Let's go back for a second and review some of the tools that the workflow used to generate this spec, right? So we've got task decomposition. It took our idea, it thought about it, it generated some concepts, and then it broke it down into demoable units, right? We've got progressive disclosure. Start with a core understanding, right? So it did a little bit of exploration of the code base, then it checked out the spec, it did some examples of what it would want to build, and then it built on those core examples, built it out further, right? It's stair stepping, it's growing its understanding of what it's trying to do bit by bit. And then we've got serialized external state, right? So all of that information that we just built, that spec, the open questions, they're all saved outside of the chat. We can ensure that if we started up a new conversation, we could pick right up from here. If we wanted a fresh new context window, say you're working in a huge app with lots of code, lots of microservices, lots of different things, when you build that spec in this first stage, that's going to really eat up your context because the AI had to think about a lot of stuff, right? It had to bring in a lot of context about your code base and all of the AI ready stuff that you've got built in there. So you don't want to keep running the next conversation in the next phase of the SDD in the conversation. You want to be able to start up a new one with a fresh context window and be able to pick up where you left off from SDD1. That's where that serialized external state comes in. Right, and then we've got some dynamic context injection, right? Like only pulling in the parts of the code base that are necessary. This didn't need to look at like database models or any of that other stuff to understand what to do for this particular feature. It pulled in just the files it needed, just the standards, the patterns, and the constraints, and built just on those. We're protecting that context window with very specific instructions here. So now that we've got the spec nice and solid, the next step is turning it into a reviewable execution plan. So let's take a look at SDD2. Here we're going to plan the work to make sure that there's no drift, that we're going to stay aligned, and to control that context window very specifically. Some techniques we're going to see here. We've got some holdovers from the first one, but we were introducing another one, evidence-based validation, right? So we've got those proof artifacts that we're going to define in this task to really make sure the AI, after it builds things, it can verify what it's built is what we wanted, and that what it built is what works. So let's take a look at running SDD2. So real quick, so you can see here I've got a context monitor for my window here in Claude. We've only used up 7%. Again, this is a small app. Don't really need a ton of overhead here to be able to build this and work with SDD in this flow. So we can keep running this in the same conversation. I'll move to a new conversation for the management parts of this. But just quick caveat, some way to have a window or a view into the context window and the usage of it is critical anytime you're working with AI. All the major tools have this now, whether it's Codex or Claude or Cursor, they all have some way to give you that insight into how much your context window is being used up. One thing you won't see that though, if you're using any of the web apps, right, like ChatGPT or Claude on the web, you have no insight into how much of that context window is used except for your scroll bar on the right. So just something to think about when you're using those web apps. If it's a very long conversation, you're going to start running into trouble. Um, so let's go STD2. All right, it's searching for patterns again, and it's reading that file. we're doing, this is another example of dynamic context injection, right? Like it's going through, now that it understands the spec that it's working on, it's going to go through and see, okay, now that I know what I want to build, and now that I'm thinking about how to build it, is there anything else that I need to understand about how this particular app works? Any other context I need to dynamically inject into this conversation to really understand the ins and outs of what I'm going to build. Right. Yep. And you can see here, this is where it thinks about the repository standards that are built in and how it's going to use those to build out these tasks in a way that is aligned with what the repository standards are set up. Let's just look at those. Yep. We've got pre-commit. We've got it referenced to claw.md. And yeah, these are not really relevant. Standards confidence, high. Looks good. And it generated some parent these parent tasks. So let's go have a look at those parent tasks. Yep. All right. So here's our new file in the get state. So we'll open this guy up. Okay. Yep. It's going to create tests first, following the TDD repository standard that it picked up. And it's going to build the controller, the template, building the test first again. It's defining the proof artifacts. And then we've got another one. Here's the nav link, yep, that we talked about. So you see these align with those demoable units of work from the original spec, but with more detail as it's kind of building them out, right? And then we've got our updated test suite. Okay, so that looks good to me. Let's go back to Claude, and you
I
see
think
it
it's
here. Go ahead.
Yeah, I think it's important to call out. So all of these things, like if these are things that developers, engineers usually have like kind of keep in their head, right? Hey, I
Yeah,
need to, I've got this ticket, I need to accomplish these things. And they've got all of these things they've kind of got to maintain and they've got to say, okay, I've got to build this feature, but I need to have all of these things as outputs. Sometimes there are acceptance criteria in a story, but often a lot of this technical detail and implementation is not there. It just usually isn't, and it probably shouldn't be in most cases. So rarely did we as engineers, this is my background, it's like take time to write all of these things down in a very methodical way that I could follow through. We kind of hit the ground running because we've got demands on our time and we need to get something built. So we just hit the ground running. So what we're getting here is a very repeatable workflow. So let's just say we've got these tasks built out and they end up being part of the repo. Somebody else could pick up where I left off, right? And at this point, we've
absolutely.
got all of this ready to go, so we don't have to repeat all of that work that's already been done for breaking this down and going. So, hey, if I stop work on at the end of the day, and this is just where I stopped, I don't have to rethink and rehash all of that context to start again. So it's good.
100%. Yeah. I really appreciate the call out to um, this is mirroring the thought processes and the effort that an engineer would go through to like try and build something like this. Because that's how we designed SDD, is to think about all the things that an engineer would go through to build a software feature in a very regimented, very specific, very like best standards way. And so we took all of those and we codified them in the four prompts that make up STD. There's only so far you can get with prompts for sure, but you can, if you go through and look at the logic in those prompts, you'll see like they're just trying to really redo and implement all of the steps that an engineer would go through when they're trying to build a piece of software with a very good, very best practices process. That's the whole point, is like take this idea of software engineering and find a way to make it repeatable and consistent with AI. So that's what we're doing here. Um, Right. So we've got the four tasks, and it's like it's doing a little checkpoint here and asking us to, if this looks good, let's go ahead and make the next steps. So generate subtasks. Okay, it's doing a little bit more exploration, doing another refresh, right? This is about the that technique of progressive disclosure, right? Like it looked at some stuff, but now that it's getting even more granular in these tasks, it's looking deeper into how these current repository settings work.
And while that's going, I'm taking a look at the context window here, and we know we're hitting let's say about 9% here. If that's a little lower on the on Damien's screen here, you can see the context window moving. We're still in an okay space, but we're I'm already anticipating knowing that hey, we're going to have to start a new a new conversation, a new context when we want to get actually moving here. So it's going to give us some tasks, and then we're going to be ready to go. But if we're not thinking about that and we continue working here, we might be able to see some degradation over time if we kept going.
Yep. Yep. That's one of the most important things is like that serialized external state, right? Like all of these files, they're already written down, they're external. You can pick this back up, or another engineer can pick this up, right? Like if you're working on a very big feature, something that's got some real legs and it's going to take like multiple days to work on, you can build this spec with another engineer, coordinate on it, and then even hand it off to a third engineer if necessary, right? So it's this external state that is mapped and make sure that the process and all of the thinking that went into this feature implementation are not just stored in a random chat with a random AI on some random engineer's laptop. It's in the repo, it's committed, and you can come back to it or hand it off to whoever's working on it. Okay. Yep. So it built some tasks here, and it's also there's another validation gate built into here. It's now going to audit those tasks against the spec and against the repository conventions to make sure that everything looks good. We'll talk about this like throughout the demo, but you'll see that working with AI, one of the most important things is having these little validation gates all throughout the process. These are the things that help maintain that direction we talked about. These are the guardrails that make sure that what you're building with the AI stays in the direction you want while maintaining that speed. All right, well, it's chugging away on those. Let's take a look at those updated tasks. Right, so it made a table of all the files that it needs to edit as part of this implementation. Right, so we've got all the translations. Right, we've got to the data tests, controller, the playwright tests. It's got some notes. Java, Playwright, TDD is mandatory, right? Like it's following those repository conventions as we build out these tasks. It's got the pre-commit hooks. Yep, and it's got some translation stuff it's going to work on. Right, and here are our detailed tasks. So it took the high-level ones and broke them down into explicit steps, right? Like, so if you're a software engineer, you're trying to build this manually, these are all the thought processes you'd have as you tried to build this out, right? These are all the things that you would have to do. This might be like your checklist that you created when you're planning it. These are all the things that any software engineer is going to come up with as they build software. Yep. Okay, this all looks pretty good. Again, we're breezing through this a little bit for demo purposes, but it's all here, so you can make sure that what you're asking the AI to build is aligned with the goals you have in mind, right? And again, it's not set in stone. If you see that, let's pick a good one here. Yeah, if you see some difference, if you don't want it as a table, if you want it maybe as cards or something like that, you could just highlight this and say, hey, Claude, change the way you're going to implement this. I've got a different idea now that we've thought through this some more about how I want to do this. It's not static, right? Like it's dynamic. It's a conversation between you and the AI to make sure that what you're building and what's going to be produced is exactly what you want. This is a way to do some design and planning with a partner, with the AI. Right, so yeah. Yep, all these tasks look pretty good. Let's see what the audit came back with.
Yep. We've done this a few times, so we're pretty confident in these tasks that are being created, and so we can just blow through it. And we're pretty confident that we're going to get good outcomes.
Yeah, yeah. I've implemented the upcoming visits page more than once, I'll say. Yep. So I need to flag. So I did an audit and I found a couple things. Let's see. Okay. Select file. Ah, okay. Yeah, we've got a few things that it needs to do. The gate's passed, but there's a few things that it wants to tweak and make it better. Yep. Okay. Yeah, it's found a clarification about the end-to-end test and like a helper that might be necessary, because this is how non-determinism creeps in, right? Like it sounded like a good idea, sounded like we had everything figured out, but now we've got a validation gate in there that caught a few holes, a few things, because the AI is not perfect. It's not going to think of everything in one shot. You need to have these little validation gates all throughout your AI processes to make sure that it's staying on the rails. Those fixes look good. Let's go ahead and just tell it it's approved. And it'll make some changes to the task file, then perform the audit again, and then we should be good to go. You can see how our context window has grown. Like every time we ask it to dive a little deeper into the code base, every time we ask it to look for a little more context or pull another website reference in for a technical reference, all that stuff adds to your context window over and over again. And also, remember, the entire chat gets pushed into that context window every time. So the chat is getting longer and longer. Your user messages, new files that are getting pulled in, the responses from the AI itself, all of that goes into the context window and starts eating up that limited resource you have. Right, so here we've got where it's specifying the helper it talked about, and now it's doing the audit again. Cool, looks like we're passing here. No more flags. Approved and applied. Yeah, we're looking good. All of our audit gates pass. Got a little summary of what we did, and where it says we're ready to begin the implementation, right? So now that we've got the plan approved, we can move into execution with evidence and start building it. So let's go take a look at what SDD3 is going to bring. Let's see. Looks like my share is being a little strange. Let me see if I can get that working again. There we go, SD3 build. So now that we've got the plan, we've got the tasks, we've got everything planned out, we're going to start building things. So these are some of the techniques. You can see a few of them again. Serialized external state that comes back. Now we've got human and resumable checkpoints, right? We saw a little bit of these in SDD 1 and 2, but that's really going to come to play in SDD 3, where it's going to have these built-in human checkpoints. A lot of the term you'll see a lot nowadays is called human in the loop, where you've got checkpoints to make sure that the human is plugged in and has an opportunity to like say, okay, yep, this looks good, or no, we need to go in a different direction. That's another thing where you want to have some guardrails on this AI speed. If you don't keep track of it, if you don't keep what's going on, focus, it's going to just go off the rails really quickly. We've got some reasoning protocols, right? Logic built into these four markdown files that tell the AI how to think about certain components and certain aspects of the process and how to build them the right way. And then we've got evidence-based validation, right? So this is where we're going to deal with those proof files and those proof artifacts, showing that the AI built exactly what you wanted. That's the receipts. That's how it shows what it did is what you wanted. So let's go back over to Claude. Since we are at 12%, let's take a look at the Git status, right? So we've got three new files here. Let's go ahead and have Claude commit those. I've got a conventional commit skill set up. This is one of the things we've got in our AI prompts library. We'll go over those more in future videos where we're going to talk to you about some of the other tooling we've built at Liatrio to help you manage your day-to-day as a software engineer. You can see it loaded up the skill. It's looking at all the files, and it's going to do and it's got a few validation gates here inside that commit skill to make sure that it's going to create a commit that aligns with our expectations and the conventions that we have established as a company at Liatrio. Right? So it runs pre-commit, make sure everything's going, and it got yeah, it's good old markdown lint. So it's going to fix those, run the pre-commit again, and we should, yep, all the hooks pass. So now it's going to make the commit. This is a great example of using AI to handle one of the sometimes annoying parts of software development, right? Like writing good commits, absolutely crucial. Doing it well, sometimes tedious. With AI, that tedium goes away. It's just one word for me to just trigger this commit thing. And we've got a report, we've got validations, we've got output. Let's go take a look at that commit here, right? So this is the commit. We've got a great message. We've got our co-authored message, all the information here, and we can see, yeah, so this looks good. We're in a great stopping point for us to open up a whole new conversation. Now we've used 12% of our window, still in the good spot, in that sweet spot zone where we don't have to worry about it. But let's demonstrate how you can pick this up, the STD workflow, from a brand new conversation with no problem. So
Yeah.
now,
I actually think that the get that was getting into the questionable context window space where since it's still a 1 million context, it was probably over 100,000 tokens. So
yeah,
I think we're at the right spot where we really do need to swap over.
yeah, 100%. So all we got to do is enter the prompt. It's going to reference those files, that serialized external state that's already in the repo. Yep, it's got logic. You can see it's found them. It's got some pre-work. It's found the task file. It reviewed that audit. It made sure that the audit had already been done and that we're good to go for continuing work on these tasks. And then we've got the checkpoint mode, right? Like, so we've got it built in here so that you can tell the AI, okay, yep, I want to follow this development extremely closely. Like, I want to see what you do for each subtask. So it'll do them one at a time, come back and do a human checkpoint with you. Is this right? Is this the direction? This is great when you want to, maybe you're working in a code base you're not as familiar with, and you want to follow the development process very clearly because you want to learn like what it's doing and how it works and learn more about this code base yourself. Or on the other end, we've got batch mode, right? Like you understand the code base, you are very confident in your spec, you're very confident in the context window and the size of this feature, and you just want to say run it all and see what happens. So that's a good experimental mode. Task mode, the one in the middle, the recommended, probably what you're going to use most of the time. So you can really stay connected to the work and validate and do some human in the loop validations after the work gets done. That's the one we're going to choose now. So we're just going to tell it 2 for task mode, and we're going to let it start building.
We finally get to build some things. Amazing.
Finally going to write some code, right? Like it's very satisfying, right? For as a software developer, to just get in there and like, all right, I want to like map out the code and like we're going to need these files and all this kind of stuff. Working with AI, it's a different way of working when you're doing it this way with these specifications up front.
Yep, and I'll bring that up again. It's for the average engineer, software engineer that's had this as their career. Writing code has been their career. This is a bit jarring. It's a little bit different, and it does take a lot of reps and a lot of just effort to get here to be comfortable with the workflows and understanding. And that's where the large lift is getting into this new way of working and understanding where that the intent and the outcomes are bit more important than just the syntax and the code. That's just going to be something we fight with as we go through, especially more senior engineers. They are a little bit more resistant, hesitant, but again, we'll have the receipts and we'll be able to see that this is all going to be good.
Great. Yeah. That's a huge part of, the way we built STD was making sure that it shows you the work, right? Like it shows you those receipts and it's got a window into what it's building and how it's building it to let you follow along, right? Because AI, it's new for all of us. This stuff didn't exist 3 years ago. Claude itself is not even a year old, right? Like, so these are all new ways of working with things. And in order to establish that trust in them and establish the understanding that they can produce good code, good patterns, good stuff, you need to have a window into them. That's where STD makes it different, right? Like you're seeing exactly what it's going to build. You're going to be able to approve it. That's why we made it this transparent workflow. It's not just a tool for creating software, it's a tool for educating people about how to use AI.
Yep. And even more just to that thread, I use AI quite heavily to help me understand an unfamiliar code base. That one of the biggest benefits of this is like, again, we're not putting our brain on the shelf. We can understand problems a lot more in depth and a lot sooner than we could have earlier, right? Just by using AI to understand and explain new tools, methods, and specifically like implementations that happen inside our code bases. And all of those things are excellent inputs, not just for me to learn, but also back into the process for the standards and implementation that we want to carry forward. So I don't see this as an out for learning at all. It's just we're intentionally learning other things a little bit sooner than we would have otherwise.
100%. Yeah. This is a great example of like that learning phase because I am not a Java developer like at all. It's not something I learned, not something I trained on. But having the AI be a partner, right? Like, so I just picked the idea. I want a new page that shows upcoming visits. If I were to develop that in a Java app on my own without any AI, so much research, so much different understanding I would have to earn and like really go into before I'd be able to even approach this task with an AI and an STD workflow like this. It becomes much more approachable. I can see all the work it's doing. I can see the patterns that it's touching. I can see the plan and dive into it task by task to really get a better understanding of what it's going to build. And then we've got guardrails at the end for our PI reviews. We've got automated AI code reviews that have Java expertise baked into them to help validate that this is a good approach. This was made the way it should be made, all of that kind of stuff. That's to do this on my own as a non-Java developer takes so much more effort.
See, we're working through still working through the first task. Is that what we're here? Just following through, following along. You'll see a lot of the Java
Um,
code being added. I saw some SQL queries being updated.
Yeah, that's one of the cool things about having these things externalized. Right. Yeah. So we can see the edits that it's making to the task file as it goes through it. So if you wanted to keep up with what it's doing, just take a look at the task file. The logic for maintaining this as it builds things out is built into those prompts, right? So if you go and look at the prompts for STD3, you'll see there's validation gates in there. There's checkpoints. Say, all right, keep the task file updated as you work through all of the different code that you're talking with. Yep. All right, we're up to 1.5. So it should be starting to run the test. Let's see what that looks like.
And this is why I keep an IDE around. I do like to
Yeah.
follow through and look at these tasks. You know, Damien's very terminal heavy here, so a lot of us might have other IDEs or other editing tools that allow us to highlight some of the features or view the markdown files in a little bit more of a human readable format. So no reason to abandon the IDE completely. It's a great review tool.
Yeah. It really depends on the type of work that I've been building here. The type of work that I do. If it's very like greenfield and it's something that I really want to be very connected to, 100% I'll use an IDE because I want to be able to like get into the code and like see those live edits. But in a case like this where I'm not quite as close to the code and I don't need to be as close to the code, I'll just do it in the terminal. But you do see like I've got a tool, like an external tool. I don't want to read bare markdown. I want to have something, render it, make it a little more human readable, right? So that's why I use these tools like this. Okay, cool. So we've got 1.6 finished. Let's close this guy out and go back to Claude. All right, it's ran the test, and now it's going to create the proof artifacts. Okay, so this is probably going to run some Playwright in the background to see what we can build out here.
It was brought up in the little bit of the chat that we our scripts and skills something we want to use and say absolutely. Like we know if we know specifically the outcomes we want to add those to the process of the workflow, and that's why spec-driven development, the implementation here is extremely extendable to so that you can add those things into the process. And here we are. This similar to any skills you might build, this validation and verification checklist is just part of that. So to fight back against any of the non-determinism of what the model might be throwing at us, we've got the validation steps built in here.
Yeah, yeah. The workflow is really designed to give you that transparency into what it's doing, right? And that transparency, that step-by-step window into what's been executed and what's been built is another differentiator between SDD and tools like Hero and SpecKit and Taskmaster and BMAD, right? Like this, if you want to get really into what it's doing, you can follow along. You can see all the logic. You can go look at the prompts and see how the logic in those prompts created this verification checklist. So you can understand how to take these AI techniques and these AI concepts we've been talking about and apply them to your other AI work, right? Like maybe you're building a custom agent, maybe you're building some kind of AI functionality in the apps you're working on for your company. Now you've got a much better understanding of some of the things and the guardrails and the checkpoints and the validations you need to build when you're working with AI. All right, so it says it's done. Let's go take a look at those proofs. Right, so let's go down to the commit. We've got a few different files in here. Yep. So here's our proof. We'll go ahead and open up the proof and see what we've got. All right. Correctly retrieves within the date window. It's got new records. Visits all 6 tests pass. Yep. Full suite runs. We did some TDD, so there was a red phase where it didn't work. And then we're going into the details. Yep. Okay. We got some information here about the test it ran. Ran a full test suite. What it proves, the tests were written before the implementation. Strict TDD compliance. Okay. And then we've got our conclusion down here. Implemented correctly, all 6 boundary conditions. We got our cycle and the full test suite passes. So in those cases where you want, this proof serves a couple different functions. It gives you a window into being able to verify what was built against what was specified. It's got command output here. It's got the command that it ran. So if you want to go and verify this yourself, you can go and run nvn test or nvnw test. Yep, and it's got specific test here. So this is a good example of the workflow showing you the receipts, showing you a way to have a window into what was built, how it was built, and how it's been validated.
Hmm. Yep, we could absolutely go through, run, debug, step through the code here and see, see the results live. Additionally, like you, yeah, you see that it went through test-driven development, TDD, adding the test for the implementation. I traditionally didn't really like tests running TDD ahead of time, writing the test before I write the code. I didn't love that as a maybe a lazy engineer. I would probably put off tests and end up we'd have some sort of a separate test writing story or something like that. Or if these things are just things that we might see put off when we shouldn't, right? And this is something that's been just a big lift for me, being able to get really TDD for free or tests for free, as opposed to being able to think about them separately. A lot of time I'd spend more time writing tests than the implementation, and that honestly was toil in my opinion. A lot of folks, Damien might disagree. He might like writing tests, but it's not. not the same for everybody, but this is a way to ensure that they get in at the beginning so we don't drift.
Yeah, yeah, 100%. I come from a QA background, right? So I spent a long time writing a lot of automated web tests and stuff like that. So I understand absolutely importance of testing, and that's one of the things that went into like how we built STD, right? For sure. But just because I've written a lot of tests doesn't mean it was fun to do it all, for sure. It's definitely some toil in there. So yeah, it's awesome to see uh, STD provide a way to take some of that toil off the hands of developers. Yeah, so we got it to build this commit. You can see, sorry, this spec and this task, number one, that took a little while. We're going to go ahead and kick off the rest of those tasks, but we're going to look at a separate implementation I did of these features in a separate PR. Let's just get this cooked off. You can see, yep, it sees that task one is complete, and it's going to go ahead and build the others. Yeah, all right, so we can come back to this, but to show you guys a little bit more of a window into what the rest of the flow works in the time frame we've got here, let's go ahead and talk about SDD4, right? So verify. So imagine we've already gone through all the tasks. And now we need to verify that what the app built, sorry, what the AI built matches all of those specs that we talked about and everything that we built and planned out up front, right? So we've got a few, all the same AI techniques we talked about before. Structured outputs, we've got a validation proof, evidence-based validation. It's going to go through and rerun all of the tests from before and run all of the proof artifacts, going to evaluate all of those, make sure that those proof artifacts show that the AI built exactly what was specified. Some more dynamic context injection because we're going to start this in a brand new window, so it needs to reestablish the context for working in this app all over again. And then we've got plenty of reasoning protocols in there for change analysis, commit mapping, reporting, all of that stuff. So that is how the verify flow works. Let's go over to the PR I've got, built this yesterday, showing another implementation of this upcoming visits page. I'm going to leave Claude running in the background there. Right, so here is, this is from a different branch, the V1. You can see it's got pull request, we got files changed. Let's find that validation report. Yeah, so here is the validation report that it made for the previous version. Let's see how this looks in GitHub. Yeah, okay. No, that's the tasks file. Sorry. Let's see. Make sure I click on the right one. Validate. Yeah, this should be the one. Here we go. Right. So, top of it, we've got an executive summary. Overall pass. No gates tripped. All the blockers are clear, and this thing is implementation ready. We can see it verified all the requirements that were in there. It went through all the proof artifacts, and it even went through the files changed list, right? So 14 core files, 9 listed in the relevant files, and then 5 unlisted. So we had that file list as part of task 2, right? Or sorry, STD2, where it generated the tasks, and it had that task, the list of the files that it was going to change at the top of that task. This validation thing goes back and looks at that list, compares that against all the files that were actually changed as part of the work, and says, does this make sense? Do all of these files changes actually line up with the expectations from the spec? So, yep, 9 of them were already listed, 5 were unlisted, but there's traceability for how those needed to be affected, right? Because as we've all seen in any software development, you can plan as much as you want. It's extremely hard to account for everything in your planning. So some things are going to change during part of implementation. These STD prompts, this validation workflow, has some logic baked in to account for those diffs, right? For those times when things change and don't exactly align up with the plan.
I
Right.
just want to call out here that the auditability and traceability for all of the work that's been done by you working with AI is all here. And this is way more traceability, visibility than you'd get in a normal software development workflow, right? You might have a ticket, you might have stand-ups, and you might go back and forth, but it's all here from start to finish and can be basically replayed from the beginning. So anything that you want to know how something was implemented or the approach or the prompts and the details, the specs, it's all here and can be committed. Your team can choose whether or not they commit all these things and keep track of them, but we think they're
Mhm.
great for all of that traceability and visibility.
Yeah, we've all been in the situation where you've asked to review a PR, right? And so you go to the PR, it's got an empty description, no details whatsoever, and every commit is like built the thing, did the work, blah blah blah. So you have to try and infer and discern all of the developers' thinking, all of that engineering that went into that just from the actual code changes without any guidance, without any direction from the developer about why they did what they did. Uh, that is not the way SDD works, right? Like there's all this documentation showing you all the thought processes, all of the evidence, all of the reasoning behind why these changes were made. So yeah, that's one of the things that we like a lot about this. It makes it very easy to audit and understand what was going on, what the AI did.
Yeah.
All right, so we've got audits for all the functional requirements. Again, this one looks a little different because this is a completely different implementation of upcoming visits. A lot of parallels for sure, but it went like a little different route when it built this one.
Yeah.
Then we've got all the repository standards. So this validation phase is a whole separate validation checkpoint to make sure that those repository standards were followed. So you don't just depend on that validation of repository standards in the very first STD prompt. You have that gate in all of the prompts, right? You want to make sure that the work you're doing is always aligned with the way you want things to be built in this repository. So we've got those repository standard gates sprinkled throughout the flow, right? Conventional commits, all verified, code coverage. Yep. And then we've got the proof artifacts. So this validation phase, it goes through the code, it goes through the files, it goes through the specs that were generated, it goes through the tasks, and it verifies that every one of those are built. It also goes through the proof artifacts. Like it actually goes and looks at those markdown files and says, do these proof artifacts actually show, well, one, do they align with the work that was done in the commits? And then two, do they demonstrate that the work that was specified is actually what was delivered, right? So these are the receipts, and then you go and check the receipts. So you're having AI go through all of the processes that a software engineer would do when they're building this work, right? And then we have a couple of validation issues. Unlisted core files. Right, so these are about the relevant files, and these are the things that were changed. We've got a note here about why they were done and why they were changed, and then we got the rating of medium. So even though something was a little different than what we planned, the workflow accounted for that at multiple sessions, and then asked then made sure that it went through and validated and verified that this is okay. This is not like a huge red flag. This is a standard, understandable aspect of working in software. Things are going to be a little different. Right, so we got that. No critical or high. All blockers clear. Then we've got, yeah, proof where it went through the commits and attached those to each of the different tasks. Gives you a little idea. So it's going through, it's analyzing the work that was done here from like every aspect. Did it, what files were adjusted? Which specs were, which functional requirements were done? Do the proof artifacts line up? Does the commit history make sense? This is all stuff that a software engineer coming in and doing a code review would have to do too. Now it's all automated, it's all codified, it's all done by the AI for us. All right, we've got executions of test runs. That's another thing that this verify step does. It runs all the tests all over again. That's another point of where, another example of how STD makes this process repeatable and it's a component, right? It's split up into chunks. You can run a little bit here, run a little bit there. You can come back to it. Anybody can pick up and do this validation run on their own. They don't need to be in the same conversation or even the same computer or anything like that as the previous ones. Then we've got some more file existing text, making sure that list from the std2 and the task file, all of those files are actually in here. Got a security check. We've got some notes about how this was done, when it was done, and who did it. And then we've got completed and validated. Right. So now it sets us up for the final code review. We can do a human come in and check this stuff. We can also have an AI go over it as well. But yeah, that gets us through the validation. Let's see how Claude is doing. Okay. Let's go ahead and tell Claude to continue with both tasks 3 and 4. Let me know when everything is complete. Okay,
There were
so it's
some
going to go
yeah,
ahead.
yeah, it's gonna go. It's gonna cook, right? We're gonna let it cook here a little bit. There were
I'm
some
going to let it
questions
cook.
about the difference maybe between like a Jira ticket or an issue and specs and where those things align and how they
Gotcha.
might break down. So the challenge here is, we want to have acceptance criteria and outcomes at the user story level or the things we're used to seeing at that level. But all of this implementation detail and how this gets broken down is usually hidden, right? So, Damien, do you have any comments on that?
Yeah, so talking about, it sounds like a question about like what kind of work do I bring to this thing? Like how much guidance does it need? And I want to, while Claude is cooking on that, let's go over, we'll talk about we addressed this a little bit in our STD playbook. So this is the companion website to the Spec-Driven Development workflow, right? Like everything from the for the prompts, it's all open source. You can access everything about how this works. Here's everything that drives it, right? Everything is in these prompts. And we've built this website to help answer some of the questions about what you're going to bring to it. Yeah, so what you bring, flow input, a Jira story, a GitHub issue, a feature request, the prompt adapts to it. And I think we've got a common question up here. Might be remembering this wrong.
Yeah, there's a lot of detail in here that
There's a lot of
explains
detail.
where it
Yeah.
where it comes from, how we think about this, what the inputs and outcomes are expected, and we answer a lot of questions here, but we'd love to chat more about it, offline as we can have a real conversation about it.
Yeah, absolutely. Please take a look at it. It's all open source. We'd love feedback. We'd love input on the process. I do want to point out, I meant to mention this at the top. I'm using a kind of beta version of the Spec-Driven Development workflow right now. Let's see. Yeah, we've got a pull request open for it right now. Yeah, so we've got some changes in here that really have improved it and are doing a lot. So we're going to try and get this in maybe today or tomorrow so you guys can run this. But if you want to run this exact version, just check out this branch here at Spec Review Checkpoint.
Yeah,
Um,
Damien's just calling out. We're always improving this as we get feedback, looking for more, validation or clarification as this one hardens a little bit. As models improve, as more let's say more tools or processes or widely kind of adapted, we bring these things into this flow, so it's always improving.
yep. All right, so let's see how Claude's doing. All right, it's about halfway through task 3. Okay. While that's going through, there is one component of the spec-driven development flow that we didn't really get to see. That's the questions file because we started off with a very well outlined task, right? It was already a GitHub issue. It had enough acceptance criteria, enough details that when the AI started work, it didn't have to ask us any questions. So I wanted to show you real quick while that's cooking an example of what it looks like to start with something fresh, just to generate what the questions look like. So I've got a prompt in here. So let's go ahead and start up Claude again. And we're just going to have Claude help us build this really quickly. I just want to show you guys what the questions file look like. So we'll go ahead and get std1 in here. And we'll say follow the prompt in at calculator prompt. So it's going to load up the STD1 instructions, and then it's going to read that calculator prompt. Yep. Now it's doing all the stuff we saw before, assessing project structure, looking for repo standards. This is a completely empty folder except for that one prompt. So it's um, a very different ask, right? So you're going to see, yeah, it's doing some web search. It's going to ground itself in its understanding of the tools that I specified in that prompt. And in the lack of repository standards, it's going to look up the specific tooling itself, right? So here it's using an MCP, Contact 7, it's a very popular one for grounding the AI in the modern standards and documentation for all these different tools that it's going to use. Right, and see, it did the same thing. It went ahead and made our docs specs directory. A note on those specs directories, real quick. We like to have them in here to be able to validate everything that was done, and for the AI to give you a transparent window into what it was built. Those specs and the naming system for them were developed very intentionally to be flexible. It's extremely basic. All of the logic for how they work is baked into the prompts. That means that you can go in and after you've downloaded these prompts, you can adjust that logic. Say you want to name all of your specs after Jira stories, right? You don't want just 0, 1, 2, 3, 4. You want it to be named after the Jira story or the GitHub issue or maybe a date. You can go in and change the prompt logic and make it work with whatever system you use at your job. So it's one of the ways to differentiate SDD from some of the other workflows that you can see like BMAT and SpecKit and those kind of things. They have very prescriptive, very constrained and really opinionated ways about how the repository structure is supposed to look to work with those tools. SDD makes it much more flexible. You can set these up however you like. Just need to go and edit the logic in the prompt so that it maps them to the system that you're using. Okay, right. So, oh, it's decided this time. So last time I did this, it said it needed to ask me some questions. So now you can see non-determinism comes in. Sufficient no questions found required. So let's see if we can, let's just undo, or sorry, rewind. And we'll see if we can get it to generate a questions file for us again. We'll give it a little prompting too. All right, so we're going to leave that one running. Let's go back and look at Claude over here. All right, so we just started on Spec 4. This is oh no, wait, we just completed Spec 4. How handy. Okay. This is a little bit window. You've probably heard the term agent orchestrator, right? This is what being an agent orchestrator can look like. You've got multiple Claudes running at the same time in different windows, and you're checking in with each of them, right? Like you kick off some work here, and then you come back to it in another terminal. You follow up. That's where those proof artifacts and all of that output from this SDD workflow comes in really handy because when you're in the agent orchestrator position and you've got multiple of these things running, you need a way to quickly ground yourself, to like quickly reorient yourself on what was being done. So I came back here. I can see a really nice task list. It's very easy for me to see exactly what Claude was working on and what Claude did. So got our proof artifacts, all three of these. We'll come back to this in just a second. Let's see if we got a questions file. Yep, we got a questions file. All right, yeah, it's asking us. Let's take a preview of that. Open questions file with Typora forming.
Yep. So you can see the importance of being comfortable with these new workflows, and in order to get really just familiar with this and have a uh, have our high expectations met of things that are high quality and repeatable, it does take a little bit of work, right?
Yeah, it totally does. Yeah. Um, there's all. It's AI, like we said earlier, AI is new for all of us, right? Learning to work with these things in very specific ways it's a monumental task, right? It requires lots of reps. It requires learning a lot of new things. We developed STD as a way to help you learn those things. Um, right. So the question file, it's a great example of this, right? You have a good idea, you know it can be built, you don't have all the ins and outs figured out. So let's take a look at some of the questions, right? Which operations make sense? How basic do we want it to go? And then it's got a recommendation for it. Full basic set. You know what? Let's keep this one simple. Let's just do A. We don't need to build a scientific calculator. Input mode. Expression. Okay. Subcommands. Interactive REPL. I don't think we want to do a REPL.
Yep. And
Yeah, so let's
just to
go.
cover this, like, this is a separate work item than what Damien was working from on the
Yeah,
other.
yeah, yeah.
Just to call that out again, it was like we took a left turn while Claude was working over here on something else. Damien is able to say, okay, well, I've got this other task that I want to start and work on, and it's a much smaller scope, and we're able to run those in parallel. Just to echo that, it's a different project altogether.
Different project. Thanks for that. Yeah, so I just wanted to go show a way you can see what the questions file would look like. If you needed a little help in STD1 where you've got the idea, but you need a little help clarifying it and planning it out, or if the AI doesn't have enough information, like if it says, okay, that's a cool idea, but I need a lot more info to be able to build this, this is what that question file could look like. We can leave this here though. We don't have to answer all this. Let's just say, come back to our calculator later if we need to. But that's another thing about STD. That question file is now in the Git repo, right? It's there if you can come back and you don't have to depend on the state of the conversation. Because that question file is in there, I could run the STD1 prompt all over again. It would see that the questions file is there and it would just pick it up. It's not dependent on the conversation that we were in. But yeah, let's go back to where we are. Right, so we've got all our proofs for all of the different tasks. Now we're ready to run the validation step. So let's go ahead and have it commit. Let's see, are we in a clean state? All right, it's already handled all of the commits for us. Yep, mark all tasks complete. So now let's start up a new chat again. We're back on the Emerald Grove and developing our visits, upcoming visits feature. So let's do SDD4, validate the spec implementation. This is we already kind of went over what that proof file looks like what that validation looks like in the other PR. Now we're going to see what it looks like to try and build it live. This one is going to take probably a couple minutes to print through. Do we have any other kind of questions we want to talk about, or Robert, anything maybe I've missed as we've been going through this?
And maybe no active questions here that need to be answered here. I'm sure we might have missed something. So if you have any questions, please add them to the chat here. As far as just things you might have missed. I think this is really comprehensive, right? And we know, thank you for your patience for the attendees here. We know this is taking a little bit of time, but really this is an important piece of the equation here. Is this is not YOLO, this is not vibe coding, this is intentional approach, right? So it is methodical, it's a methodology. Some people might say, hey, this is a tool. Okay, sure, but this is really a new workflow, a new way of working. And again, this is our spec-driven approach that is actually working for real implementations, real customers, real time, real life, right? I think just to cover any of the things you might have missed, the we've blown through it pretty quick. The just recovering on some of the things, it's important to read all of these things because this is where the contextual like intentionality really shows up. I know we're not looking at the code as much as we would have in the past, but just to really just echo how important it is to be intentional with this.
Yeah, yeah. And it's we haven't looked at the code yet because we haven't gone to the code review phase, right? So
Right.
we're trusting because we understand how the workflow works and we got all those validations, right? Like we had a very explicit plan at the top, lots of direction. Then we had a very explicit implementation phase that worked on that plan, and then we were going through a validation phase. We can be confident from this that it built what we wanted and what we specified. And after this, we can open up a PR. We can see that PR, and we go through all the typical review phases that any kind of software building would go through. So we can look at the code. We can look at the code review, and we can see if there's any gotchas, if there's anything in there that we weren't expecting. And one thing I want to point out too, so we're about to finish up this validation phase. We've been on this for, a little over an hour and a half. I definitely could not have built this functionality in a Java app by hand in an hour and a half. Absolutely no way. And especially not with all of these validations, all of that extra tooling and documentation showing what was built and letting another engineer come in and validate this very easily. All those commits that have really good hygiene, all of the task lists and all of that window into the thinking, that wouldn't exist with any other project when you're working with a human. So it's just an example of how AI has that speed, has that capability to just build a ton of stuff very, very quickly, and how SED gives you the guardrails and the wrapper around that speed to make sure it stays focused and it's building exactly what you want.
Yeah, just to briefly talk about that, it says most of our work is going to be joining, maybe it's 50-50, greenfield, brownfield, but the importance there of if someone's new to a team, new to a project, which happens, right? We've got rarely in the enterprise software world will have the same team that started a project in the project or someone that's working on a product that's been around for years, they're going to be in and out, right? So having all of this historical data as this matures and as the product evolves is going to be huge for anybody that wants to do any of the work. Like if they're coming in, they're never starting from zero, and they're easily able to review and come up to speed a lot more quickly than that would ever happen before, right? So we're not leaving these folks to weeks and weeks of onboarding just to be familiar with a project. These are all new ways of working, but the importance there is that we get so much historical and additional context that we didn't have before.
Yeah, yeah, yeah. And I hope that this serves as like an example of how for developers that aren't familiar with the tooling or like aren't native developers in whatever repository, SDD is a way for you to bridge that knowledge gap, right? Like it's a way for you to take an idea or some work you need to do, like from a Jira issue, and go and start implementing it and learn how to work in the code base alongside the AI, right? You can, if you pick the mode that goes through each subtask individually, you can have it execute on a subtask. Then you could even in the chat say, okay, I've read the code. I still don't really understand everything that went through this. Walk me through these changes. You can use AI as a learning partner, right? As a way to help you understand what happened and how to uh, get up to speed on the code base very quickly. Okay, so yeah, we've got our validation report here. It took about 5 minutes to go through. Looks like we passed everything. This time around, we didn't have maybe we didn't have any of the validation issues. Let's take a look at the file and see. Here comes me, knowledge report. Yeah, so validation. This is the one we want. Right, we've been working on spec 3. Yep, okay. So let's open up this validation report. It'll look very similar to the other one. Spec branch, yep. When it happened, pass, all the Java tests. We've got all the end-to-end playwright tests are passing. All of our functional requirements are met. All of our proof artifacts are accessible. Yep, validation gates pass. So a quick window into the validation gates, right? Like no critical or high issues, no unknown entries, all the proof artifacts, no out of scope source code changes, right? We've all had those PRs where we go in and read, and it was a PR for fulfilling a very specific feature, but it also includes maybe some extra stuff, some stuff that's out of scope. Scope creep is a real thing. It happens. with the SDD workflow and these AI guardrails, scope creep is a non-issue, right? Because there's so many little validation gates throughout the process to make sure that it stays focused and implements exactly what you asked it for. We've got a gate for checking repository standards. And right, another thing, it thinks about security, right? There's no credentials in here. There's no security stuff that's going to trip up this being pushed up to a remote repository where maybe it could get be public or it could be codified in some way you don't want it to be. We've got our coverage matrix again. Yep, for all the different units. A little different format here. It's spread them up by the units. That's one of the non-determinism ways, right? Technical requirements. Yep, these are those open questions that we had to think about before we even began any coding, right? We've got repository standards. There's the template, the controller package, translations, test-driven development, conventional commits, and pre-hooks. Yep, all those in. We've got our screenshots. I don't think, yeah, let's take a look at one of those. Yeah, we'll take a look at the proofs for which one is this? I'll just take a look at it and we'll be able to see. Oh yeah, we've got the playwright report. Okay. These are some of the proof if artifacts that we can take a look at and see exactly how these things worked out. Let's have a look at our files here.
Again, way more validation and coverage than the average engineering team would take time to create all the documentation and proofs and things like that. So the more automation we put in, the more we'll be able to have and track and have traceability. So we'll have more confidence in all of the outcomes.
Yep, 100%. Uh, okay, so we've got our all four test paths. We've got the HTML report. I might open that in a second, but I'm looking for, here we go. Yeah. So nav active state. So one of the things that you get in these proof artifacts, right? So normally to validate that this functionality works the way you want it to, right? You'd have to spin up the app, you'd have to navigate to it, and or you'd have to deploy it in a deployed environment. You'd have to navigate to it and like visually verify it. With these proof artifacts and the way these markdown files are structured, you've got a summary telling you what it's doing. You've got evidence, and then you got the screenshots right here. There's our upcoming visits right at the top. So I don't need to go and spin up the app just to verify, yep, that looks good. That's in the right space. We've got the screenshot of what the page looks like. Yep, and it's still there when the page is not active. So it's just another example of how the SDD workflow tries to save time and still provide that visibility into what was built, right? You can look at the code, absolutely. You can look at, you can run the apps yourselves, but these proof artifacts, they save you time. They give you the screenshots right here, let you validate everything, and then move on to the next thing very quickly. What else do we have in our validation? Let's see, what do we look at? Right, we were at proof artifacts. Yep, all those in there. Got our HTML report from Playwright. A couple of validation issues, non-critical or high. Let's take a look. Issue, place an over package rather than server package. Okay. I can see that. Sometimes code needs to go in different places. These are like decisions you make on the fly when you're a developer, right? Which one of these is better? Is there a big consequence for picking one or the other? No? Okay, we just picked one. So this is a good example of how the implementation varied a little bit from the spec, but when we had a validation, when we went and verified it, that's not really consequential. It's okay where it is. Yep, something about translations. Right, we've got some Windows line ending stuff. And we've got some markdown lint failures. Not a huge deal. Nothing that would block this going out and getting pushed up. Then we've got our commits validations. Yep, went through each one of those, talked about what they do. No out of scope changes. Again, making sure we didn't have any scope creep. Make sure what was built was exactly what was planned. Got some test results. Again, you could go through and run these yourself if you want to validate them. And if you want to make sure that the proof artifacts are showing exactly what was run. Yep, we've got playwright tests, our file existence check all over again. Yeah, and that's a validation of another successful implementation of a spec. We can definitely, next steps would be have Claude open up a PR. Can go ahead and kick that off. Looks good. Open a pull request. We've got another skill. This is another one available in our AI prompts library online. You can see it pulled in for creating a pull request. That's what gets you that good formatting for a pull request every time. Another consistent toil issue, right? Like you tell the AI how to do it once, package it in a skill, and it remembers how to do it from forever. So yeah, now that we've got that up and running, now that you've seen the four phases of SDD work and how they work, let's zoom back out and go back to our slides and take a look again at the presentation, or sorry, at the workflow as a whole. In the beginning, we had phase one spec, right? We generated the spec, we answered some questions, we made sure that what we want to build lines up with exactly the idea in our head. Then we broke that down into tasks from the spec, went from a fully fleshed out idea into a fully fleshed out implementation plan with tasks for all of the different phases. Then we went through the implementation, right? Now that we know what we want to build, let's run the phase three, the build with all the specific guardrails that keeps the AI lined up, takes advantage of that speed we talked about without going off the rails, but keeps it, keeps it all in the same direction. And then we went through verify, where we take a look at everything that was built. We do an independent validation in a completely separate chat. No like sycophancy going on with it trying to please us about what was built in that conversation. It's a fresh context window. We don't have any layovers, like any holdovers, and we're doing that validation fresh. And that's how that full cycle leads to the like larger pattern that I want you to remember from today, right? This is the Liatrio Spec-Driven Development. This is the reliable AI playbook that we've built to help you guys have really good success with AI when you're building software.
Thanks, Damien. Yeah, so just to close out here, I know you've been with us for a long time. This is a kind of a long webinar, right? But this really to show the ins and outs of how this works, and it's not a small effort, right? It is a new workflow. There's a lot that goes into it, but that's why it's important. If we want good outcomes, it takes some thought and approach. So just to close out here, we will be doing more webinars to kind of extend on this with MCP and other skills and how that can improve the workflow in the next webinar. And hopefully we'll have that in about a month. So check out your socials, LinkedIn. We'll reach back out. We'll get all of the resources. We'll share out this. This is being recorded, so we'll try to share that with y'all as soon as we can get that packaged up. But we'd like to engage, reach out to us online, and we'd like to have more conversations about how this works and talk about the successes in the wild and how that's helping us all day long. So
Yeah,
thank you so much. You can reach out to us, connect with us on LinkedIn. Thanks, Damien. These are our LinkedIn profiles, but we're really just thankful that we're able to share this with y'all. And please, yeah, connect with us, and we'd love to chat again in the future.
appreciate your patience and thanks for the interest, y'all. Take care.
Thank you. Have a great day.